Hello everyone, and welcome to an architecture meeting. I want to kind of show you guys some of the GT bridge that I've been working on, and a contributor from the GT team has also helped contribute to as well. It's actually in a usable state that we can all kind of use now. So we can do very basic things. I'm going to show you how to turn it on and off. We have this nice book, so if we go to knowledge bases and we look at GT beam for Leoparder. Yep, this one right here. I mentioned how we can connect to an existing image. So there is this thing right here. I also show you how to execute it from Elixir. You just run GT bridge, HTTP server, server start, and then you can run this right here to connect to an image. And to show you that it works, I have a bridge here. I'm gonna kill it. Let me do the bridge.http. So I started up a bridge there, and if I run this, we can see that we're connected. And what this means is that we can do things, and I'm going to set the debug log to none for this. If we run this, we can see that we get hello beam, which returns a byte stream, and we have the printed text over here. What I'm going to do to make life easier is move this over here to 9, and we're just going to make this be the main screen over here. Okay, great. So I can show you some other things that we can do. For example, I can evaluate an expression, and here we have a map of high, A to high. You can click on this, of course, and get back the string high, and if you click on high, you get 3, which makes sense. This is just a raw view right here, and we can remember variables. So if I were to evaluate this, we get this, which is really nice. I want to, yeah, let's do it. Cool. So we can do other things too. I can evaluate this, and what's neat is that this isn't a proxy object, but this is just a byte array. So how the mapping works is that we have things called primitive types and things which aren't primitive types. So something like an array gets dumped directly into this, and note that for those, we're using a JSON encoding, and for those who know JSON, 255 is not a valid byte in JSON, but we use a custom serializer, so all this works. Atoms work, they're actually proper, and also PIDs work. So I can send self, and you can see the PID of self over here. And if I were to list all the processes, which this takes a while, you can see, and we can click on all the PIDs, and we can probably send them messages too, which is, I think, pretty neat. Other things you can do, which I think is cool, is that we can have views. So if you saw here, we have a view right here. We have a list, and I want to show you another example. So there's this example eView here, and what's neat is that we have this thing called remote views, and we have 2 remote views. One is int listed, which just lists the int value, but times 2 and times 3, and then we also display the name. Let's kind of look at how this works. We did not implement this in GT, we implemented this in Elixir. So if we look here, these are the 2 views. You just say def view, you say the name, it's just like def, and you say what you're matching on, and then you just build the list. The priority is 1, int listed, and this is the self.int, int times 2 and int times 3 that we saw right here. We also have a text view too, and the text view is we just take the title and then we get the name, and we just say name is name. You know, very basic, but you can already see that this is an improvement over base Elixir, because if we were to do this by hand too, if I were to copy this and send it in my REPL here, all we get is this view right here. A bit more compact than the raw view here, for sure. This is 1 line instead of 2 lines, but if I wanted to have custom views, like if I actually really cared about the 6 and 9, this kind of matters. What's neat is that you can also define this for any data type. So for example, let's build a view for lists. So if we want to really quickly make a list for views, a view for lists, it's very simple. Fun list view. I'm just going to take self is equal to, I'm just pattern matching, so I'm telling it what type it is. And then builder. And then, you know, it's very easy to make. We can do builder.list, list.I cannot say, priority is 2. The title is fun list from Elixir. And then lastly, let's have some items. then it's just self. Okay. We can now see, I noticed I recompiled the beam, and let's see what happens when I evaluate a list. Look, fun list from Elixir. It's right here. Before there was only list, and you can see that I'm not faking it by, if I remove this, and I type in recompile, this doesn't update right away, so I bet you if I inspect it, it does. See, right here, unlist from Elixir. So it replaced the function in memory, and great, it gives the title, because it's actually executing Elixir code. You know, something funny is if we turn debugs to, like, debug instead, watch this horrible. Notice that it just sent a shit ton of things, because for each of the values in this list, it's actually sending a signal. So you can see that it's not doing anything anymore, and it sent a signal for this. So it's actually fetching it every time. And it does caches, because notice that there's no more debug logs here. Yeah, let's look at some other things. I want to show you something else. So if you notice something, if we look at this list, besides it having this unlist from Elixir, the type of this is a beam list object. And why this is really neat is if we look at the inheritance class, we inherit from a thing called beam proxy object. And we have a few things like PID, beam teen, and beam tuple object. And how you get these to work is that you just simply say the name. Because the type of a list is list, and we can query this information, beam proxy object asks for all its subclasses, and from there it's able to determine, okay, what proxy object should we make? So if we evaluate self, you notice that it's a beam PID object because the class name is PID. And I made a custom printer that just, we call some Elixir code, so we can actually run some of this. So we can say self-evaluate, and we can just run this. And so we can actually just run Elixir code. So before I was showing you running Elixir code in Elixir snippet, we can also run it in a Smalltalk snippet, which on any beam object, you can just say self-evaluate and wait, self-resolve, and then you just put in your items here. So, you know, that's pretty nice. I don't have it set up so the self here is the object here. Actually, no. It actually is. No, wait, no, this is a... Oh, this must be because I did self here. This self isn't the same PID, so it technically doesn't have the smartest memory because I'm not sending in the context of this object to it. So you can't do cheeky things like send it back to Elixir. But you can still evaluate via this, which I think is pretty neat. You can, of course, make views here too. Like, if I was so daring, and I will be so daring, is I'm going to live code another example. Let's call this print PID. Print PID view. This is a GT view. Okay, this is a GT view. I always suck at doing this, so bear with me because I really suck at writing these sometimes. I'm just going to cheat by looking at this as I do it. Yes, we're going to return a view text with the title being printed view. Priority is, again, the API is the same as the Elixir. So, you know, if we're confused, we can do it either way, as I just showed you. Priority, and then I think I can do text is, I don't know, this right here. Or we just take this, right? We do this. And we say this. Self-evaluate, and we put this in parentheses. Well, I hope I did it. And look, we did it. First try. And the reason why I knew how to do it is because if we looked here, we did priority, title, and then we found a way of just putting the text somehow in there. And if we look at this API, it's really not too wild. You can have a title, a priority, and this is the text. Probably should rename it because technically we called this one text instead of string. But as you can see, we can define views from either Elixir or GT, and it just works. And you can do more complicated things. The Elixir API, so the Elixir API only has a few different views at the moment. Namely, we have columned list, we have column tree, column empty, list, text, and view. So we don't have the graphical one, so we don't have Mondrian. So if you're wanting to build a graphical view, like you see in my other tools, you're going to have to do that from GT for now. But this opens a lot of avenues of writing views both in Elixir, and if you are a little bit more of a power user, for I guess the Elixir people here, you can write it in GT. In time we can port over the API for the graph in Mondrian, and it wouldn't be too much work. But there's other work that we need to get to, like making good default views. Like I want to remake Observer inside of this and do some database table views as well, if possible. Does anyone have any questions on this or want to know anything?
Yeah, I'm interested in how the bridging works.
In how the bridging works?
Yeah, like
sure,
what exactly is going on under the hood, like with tooling and stuff?
Oh, perfect. I will show you. I did not write this. Someone wrote a code quality tool for me. As we all know, code quality matters quite a lot, and reading code is one of the worst ways of understanding code quality. You don't understand code by reading it, really. There's usually too much. So someone made this tool for me. So there is a few things that's happening. So I guess to give you the technical overview is that there exists a bridge between Elixir and GT. And they're using JSON for the encoding. So if I were to go here, I basically just use the normal JSON reader going back and forth from GT. But what's weird is that, as we know, JSON sucks. It's horrible. And so I have a serializer here. And the serializer is special in that we treat PIDs and base64 objects as special. So this means that the GT code, which, by the way, Neo-JSON decoder has no idea how I encoded this in a special way, has to resolve this. And I resolve this by simply looking at this other function right here, which is I check the atom, and if it's true, I just grab the data inside of, and it's a base64 encoding, then I base64 decode it in GT. So I overcome some of the JSON serialization this way. Some other ways that it works is that we are using a lazy method. So we have this thing over, let's see, which code should I show you for this? I can give you the executor handler, but it's kind of boring. Yeah, executor handler is not interesting. I guess the interesting thing here is we have commands and code for remote. No, this isn't what I want. Sorry, there's a bunch of code that I always have to remember on this because it's not obvious to me. So I guess the way it works, and I can show you from the Elixir code here, is that we have a thing called a lazy way. So we have this thing called an object registry. And this is just a gen server. And this gen server just basically stores object IDs coming from GT. So if we turn back on debug logs, we can see a bunch of stuff here. When we get a message, we end up getting like ports, enums at, and I just resolve stuff. But we can actually start dumping the database. Let me look up sys.getStatus. So we store this in a registry here, and we can see that, for example, object 18 was a bunch of these PIDs, right? PID 000, PID 010. These were spawned from when we ran that's when we ran process.list. It got stored here in an index. So when we look up, so when GT sends something over, it's like, okay, do you have this ID? Is this already registered? And so we basically cache it in here. And you notice that when I look at objects and I start looking at PIDs, these get re-registered. Because I believe we don't cache it every time. I believe we basically tell the object registry not to cache, but we store the PID. So when we have a object ID, so I can show you this. So if we look at the raw view here, we can really see that the Elixir var is 859. And so if I were to look up 859, and I have to do this through the object registry. Okay, I can get 859, and you can see that there's a PID. And what's really cool is if we look at the implementation of this, and I can show you, I want to go here, and I want to go application, execution handler. weak registry. So all these get stored on the GT side in a weak registry, right? So we end up having this map between a bunch of things where you see this PID right here, which is the 859. One of these are the 859. These basically are a weak reference. And so when they go out of scope, they will trigger a message on the Elixir side. So they will say, if we look at the language link weak Pharaoh registry that we have here, it will call destroy, and it will basically call the finalizer. And we have a implementation, not on this, but we have an implementation of destroy, I believe, on the object itself. I think if I go to the proxy object, it actually gets deallocated. It actually goes and deletes things from its application, which is neat. I can query this substring. I want to look for application. It's somewhere. Sorry, I'm horrible at finding things on the spot in this code base. But effectively, we have this weak registry. So when something goes out of scope, it can deallocate itself. So we handle allocation and deallocation through a weak registry that the Pharaoh side cleans up every so often. So this list that you see here doesn't grow forever. It will be GC'd. As for the other details of it, let me go back to this graph here. I like this graph. We basically have this entire... Yeah,
sorry, before you move on, what do you mean by out of scope in this context? Like out of scope within a certain call?
Like, for example, if I were to close this entire page.
Oh, okay.
It would trigger a deallocation because there's no more references to anything. So, like, after we're done, if like all these are still alive, because as you can see here, like, I am like clicking on them and these bubbles are still there.
Yeah.
And some variables are bound, like X is bound. It shows nil because I don't have the integration to Pharaoh, right? I can make it, but I don't have the integration to a Pharaoh snippet. Like in the Python bridge, I could say X and then evaluate it, and it would be the same. I just didn't implement this, right? But if I was doing it better, you could do that. How some of the other stuff works is kind of neat. So like if we're going back to here, there's these snippets. And so if you look at the snippets here, this is how the kind of this works here. So I did not write this code, but there is four classes. The Elixir snippet view model, which implements two methods. This is one of them, which is the shortcut. Then you have the element, which implements some things like, oh yeah, put the Elixir @ and put the you have to put the language label on there. So some just like graphical stuff and evaluation strategy, and then the snippet itself. So like, as you can see, it's not too complicated actually to make your own version of a snippet in GT for your own language. So if you wanted to do this for AL, which I suspect we will, this is all that's required really, which is these four classes. So that's how the Leoparder stuff works, right? I'm going to put it down here for now because we don't need it. Then you have the execution. So if we look at the application, it's kind of complicated. So if I look at, let's just go through here. Oh no, because this is, go back to here, kill this knowledge base because I don't want to see it anymore. Sickens me. Okay. Here, yeah, let's look at, not Y. Cool. We look at here, we look at raw, and now we can have the application. And the application is kind of complicated. We can do a lot of things. It can show the STD out, the status. What I did was I connected to an HTTP server on Elixir. You can even have a playground here, which is pretty neat. But how I end up doing that is by starting with the server and client, and it basically starts a Pharaoh link application. So we basically we inherit from language link application, and we just basically call start with all our settings. And some of these are the unique things like the HTTP message broker, which is the JSON broker. It's using HTTP. So if you're looking at the actual HTTP server, you could also do TCP. I stole the TCP code from our code base, but I didn't like the serializer because it couldn't handle big numbers, and I didn't want to implement that for message pack because I think that's really silly. But we have an HTTP server here, which we can see the router. I want to thank Christoph because I pestered Christoph like a year ago about this because I was confused on how pub works. But the entire thing is really basic. So you get a message called enqueue, and then you read the body of the connection, and then you basically get the statement here, and you just call eval. And so if you look at the messages that come in, you get enqueue, bindings, you get some Pharaoh command ID, and then the statement is always eval.notify. And so so when the evaluation server gets it from the HTTP protocol, we decode it, we call eval.eval, which then goes to a gen server, and this gen server just keeps all the bindings intact. And it also gets the message, by the way, remove. So when GC happens, the Elixir side gets this message called remove, and it removes it from the bindings, which is kind of neat. But there's this notify function. What's interesting is that it doesn't take the response from the HTTP. It expects to get an encoded value at this location of localhost/eval for some reason. I don't know why it works like this, but it does, and it's quite simple. We just get the ID from the registry. We end up serializing it with our special serializer, and then if it's a primitive type, we don't even bother with basically making it lazy. So if it's an immediate value, we just return it. Otherwise, if it's a not immediate value, we're really lazy and we just return that, hey, we have a reference to a list rather than giving the whole list. And then we return it like so. And then the Elixir, and then GT just gets the reference, and then it can look up data about the reference using views. Because as you saw earlier, don't want to go through, yeah, go through here. If we look at the list, for example, the raw view just sees 885. It doesn't actually know what lists are. It just gets back some raw data of like, okay, hey, yeah, we have an X class, which we can see here. The class is a list, and the ID is 885. And then we have to get the data with this list in this remote view here. Note that some of this is kind of hacky and bad in the sense of if we look at this, this calls asList, and asList is n squared because we're doing item at, enum at. So I want to fix this by probably crittering down the list because technically if we're being lazy, yeah, I can't just return the entire list. I have some ideas on how to fix this. But is there any particular thing you want to know about the implementation? Because that's most of the life cycle right there. Right, there's a lot of more complicated bits in GT itself for setting up the connection, but it's mostly just class plumbing. And the best way to learn the class plumbing in this is to look at this diagram that I have here, because this really helps. Because the code is kind of sprawling. The layout isn't really good for dynamic views, nor is it good for static views like this. So it's kind of all over the place. We have this beam link process here, and we have other things I can tell you some secrets in which I'm doing with this process here, because technically I always spawn an Elixir REPL, but I'm cheating somewhat. I'm not really cheating. It's actually talking to the image, but I can show you how I'm cheating. It's yeah. Do you have any specific questions you want to know?
Yeah, I was gonna ask about the connections, but if it's maybe out of scope, then maybe let's not.
Well, I can show you. So how the connection works is I just connect to the HTTP server on both ends, and so it just talks to HTTP. Now, the interesting thing is I don't actually have logic for if the HTTP server already exists in the GT. So what's interesting is when you connect to a pre-established server, you're running an Elixir shell here, but it just fails and it just shuts down the HTTP server because I always start it up even if you're connecting to an existing image. So this is a cute little hack that I did that I don't even care that if the process started here dies in terms of the server. You're technically running an Elixir thing locally and connecting. Probably bad. I think Christoph would tell me I'm bad because I run IEX-SNIX here. And Christoph would tell me I'm probably doing a bad thing here. Probably.
You're a good boy.
Okay, I'm doing good then. Seems. But yeah, but you can see has process, is it running here? We can spawn a new process with the command IEX with the arguments -SNIX. Right, so It's not too complicated. Note that I have a start HTTP and I have a start TCP because technically I can start the TCP listener. It just doesn't work. So this one doesn't work. This thing does work.
Mm. So it's HTTP, not TCP.
Yes. I don't use the TCP one. I stole the TCP code from our code base. It's quite good code. It's just I use message pack, and message pack sucks because you want to evaluate a big number and it fails to serialize. What can you do? Like, I don't want to use message pack.
So you mentioned earlier that you write views in Elixir. So
Yes.
what's the like life cycle of this? It's like you write your view.
Mhm.
I guess there's like this project is basically a dependency for
Mhm.
writing views.
Yep.
And then your Smalltalk, your GT goes and asks the Elixir that it's connected to to get this code. Is that right?
Yes, it asks what views do you have. I believe we can see it in the proxy object. I believe this asks for views. You can look at view declarations here, and what it calls is get GT bridge. We can actually run this. What's neat is that because these are just this, I can just run. Can you like stop? Eval notify. How cute. Maybe my command C didn't work on me. Okay. 885, I think we said before. Was it? 885. Boom. So this is a list view, and there's two views. This was the one we defined, and this is the default one that's in the code base by default. So it has the items, it has all the data there, and each view. One thing I didn't show is if we go to the text view, is that there's always a way of turning the data structure into a dictionary for GT. So you convert it at some point to a dictionary that it understands. And there is something on the GT side which understands this name right here, GT Flow Text Editor View Specification. And I believe I can actually show you this. Tell me if you see view declaration. Here it is, list view declaration. And so it just maps it, and there's a name here. And by the way, this works through the same mechanism. We inherit from GT view declaration, and there's a class side name for looking up all the subclasses for it. So we can look at all subclasses, and then I can run this. I have to get a data first. What's annoying is I have to get the data, but it can just run. So it just looks at all subclasses, and it looks up, hey, is there a name that matches this? Okay, great, let's use this code here to actually start doing the view. Inheritance is wonderful, isn't it? So it's pretty nice. You just do a flow view, and because you inherit it, it uses treat view, which is undefined for this, and then you just say, well, here's the items, and then you can just define the view that way.
So what if you need to like reload code? Like what happens when you like change your Elixir code and you need to update your GT?
Well, it fetches it every time. So every time you reload the code, like as I showed before, E views, it doesn't cache this on the GT side. We do zero caching. Which is
it goes
good.
and refetches it. Is that right?
Yes. So
whenever
now,
it recompiles, I see.
Yeah, so you see there, and now I'm going to look at a list again. And now we can see here, fun list. And you notice that you see how there's a bunch of spam every time I do it? It's because it's fetching all the reviews. So like instead of just one message, like watch, I'm going to click on raw so it doesn't spam you right away. It shows one thing here, and then when I click here, it had to fetch all that, and now it just spammed my screen. Right? So it's fetching the views every time from the gen server. I believe it's, if you look at this view here, remote views, views from declaration, from raw view, no, it's self views from declaration ends up calling the GT code itself. GT raw declaration. I don't know if I evaluate stuff here or not, but I showed you before how I evaluated stuff in the remote views here. It's like you look at it and then you just end up going through the entire list, and so it's doing a query always. If that helps. But from an Elixir point of view, this isn't really hard code to read, is it? Like this is fairly standard stuff.
No, this is good.
And I think with def example, we'll have examples here, and because these are all examples, so you can do def example down here when we get the example release out. And yeah, and so this has wide-ranging implications for pretty much any Elixir code we ever write. There's other work that I'm doing. For example, there is no auto-completion, but I can implement auto-completion here. It's not too hard to do. I just need to do it. I'm just bad. So, you know, if I was less bad, then I would have implemented it already.
So what kind of views are available? Because you said Mondrian is not available. What other views are available?
Sure.
Or rather, graphical capabilities. So.
Well, you can always make them on the GT side, by the way.
Yeah.
Yeah, let's look. It was text. Like. Okay, cool. Column list, column tree, empty list, text, and view. Sorry, text list, column tree, column list. That's it.
And so if you wanted to like write one for yourself in like GT, you would also need to write a bridge version, like support for it here.
Nope, not at all. Nope, I just showed you how to write a view, and it had zero to do with it because it's attached to the class in GT. So when we looked at the PID, where was the PID? Self. Great. We see this printed view, and I just wrote it as a normal GT view. I just said GT view.
Sorry, not view. I mean, like if you had a special data structure, you would need to add support for it.
You don't have to. So for example, I made a data structure here. This is just a beam proxy object. But if you're wanting a view from GT, you would want it. So for example, if I wanted to, let's say, make a custom view for this in GT, what I would do here is I would take this, and I'd click this button, and I would call new subclass. And the subclass is called beam eviews, example eviews. Let's call it example eviews. How about that? I think that's a good name. You would agree, probably.
Sure.
I hope. And then I would simply do this. I take this. I implement a new method called class name, and this is on the class side. And I just say return this. Okay. So now notice this. I think that's all that's needed. And now if I evaluate this, subclass responsibility. There's another subclass responsibility. 1 second. Let me look at the string. Sorry, I always forget. Responsibility. Subclass responsibility. Did I? It's on the class side. Yes. Sorry, I think I'm doing something dumb. What am I doing dumb? This looks for all classes, collect as dictionary. I think I screwed the pooch somehow. I don't know how I screwed the pooch, but oh, I see why. Notice here I did Elixir name, not Elixir class. You see I'm bad. Okay. Yeah, so you just do a thing called Elixir class, and then I'm going to remove this. This one is bad. How do I remove? Where is the new button? Sorry, I'm not used to, here's the delete button. I actually changed it to a delete trash can. I'm happy. Now if you look here, this is a beam example eView. And notice you get all your views from the Elixir side, and you can define your own views here from GT. So if you wanted this to be graphical, like I'm not going to make a graphical view for you on the spot just because it takes me like a minute. But you could. It's not very hard. Like I could try to do one if you really want, yeah, you have all these. Does that answer your question? It's as simple as just making a subclass and then doing this if you want to make a view from GT.
Yes, it makes sense.
Cool. Does anyone else have any other questions?
If I wanted to start, like, just jumping right into this, where would you start?
Sure. If you're wanting just to use it, I would recommend just checking out the book. So when you clone the repository, you can go to the knowledge base, and you have GT for Beam. It talks to you here how to do it. I recommend just going to this unclassified page that I never put in the table of contents, and just looking at this right here, this tells you how to set it up from Elixir. So this is what you put in your dependencies on the Elixir side. You run this in your REPL, and then you run this on your GT, and then you can run.
And this is part of base GT now, is that right? Like this is part of
No.
the main GT release?
No, this is you're gonna have to just grab it, which
Okay.
is quite simple, which is really simple to grab. I can show you. Give me 1 second. GT for Beam. Okay. We have here GT for Beam, and you just run this code right here, and then you load the leopard.
Okay.
You run this one and then this one.
Gotcha.
You can see this guy did a lot of good work. So he's the one who finished it, and he is the one that offered the cool visual that you saw earlier.
Nice.
Yes. So people take an interest in this project since it's actually working. But yeah, it's quite simple. I want to actually use this for Anoma/Anoma as soon as possible. There's a lot of cool things we can just do with it. One thing, Ray, I do have a question for you on this front. One thing that I want to do is, you know how we return string for node IDs? This kind of really sucks for making views because then I'd be making views for strings. I would like to return some kind of data structure over it just slightly, just so it has a custom name so it can have custom views. Because if you mix it with string, it's going to get kind of awkward.
Why does it get awkward exactly?
Because I'd be making views for strings and not views for like the actual thing behind the gen server or whatever. I'd rather like say here's a node, and then I can have custom views on the nodes because it means I can discriminate on it easier.
I mean, why can't you just say that the string is a node ID? Right.
I'm doing type dispatch.
all of the. Yeah, but why can't you just like you should be able to have a class in Pharaoh, right?
Mhm.
That's here's the Elixir representation of a node class.
Yes, I can do that.
And that, yeah, and that's all you have.
Yeah, but the problem I have is that if we get back a string from an example, then it's kind of hard to match it. That's all.
I mean, you already know that it's a node, or you should already know that it's a node.
Wouldn't you be able to just like query the registry or something to like say what are my node strings?
I could make a custom view for string. Like one thing you could technically do, but it's more work. I could do two things. I can make a view that's empty, but this would be on Anoma/Anoma only. So I would have this be an Anoma/Anoma package that you would bring in as well. That would for string look up in whatever registry that we have node IDs, look it up, and if it exists, then bring forward a different view. And there's hacking that I could do on the implementation to make this work better. It's just more complicated because it's not a unique type. It's just annoying. I can do it. I can put in the effort. It's more just annoying to do if you want to do that. I will do some discrimination because what I want to do is make views for amnesia tables, which just give you atoms, and so I will be implementing custom views for tables by discriminating on the atom. But it gets annoying when I have to discriminate on strings as well for this.
So like an ETS table, for example, is usually it's a reference, right? There's a lot of things that are Erlang terms, but they're also handles into
and something else.
Some...
On that note, actually, I had some ideas. So if we look at this code here, something which is interesting is that I just have a PID, but what I want to do is I want to see if this is a gen server. So what I want to actually do later is discriminate on a PID and see if it's a gen server. I guess what you can say is it's a similar technique. Yeah. Just do that is what you're basically telling me is just do the same technique.
Yeah, it is. I mean, you can for this purpose, right, set something up on the Elixir side. I think if I understand it correctly, where you just give a tuple that's like here's a PID and then some atom or some string or whatever that says what this PID is.
Yes.
You could do things like that on the Elixir side, I guess.
Yeah, that's what I was thinking for our examples potentially that we turn node IDs. That's more of what I was thinking.
Yeah, it's bizarre to work with from inside Elixir though. Then every single time you use something, you have to match out of it.
Yeah, Christoph?
I think the general concept you're describing here is that you want some form of introspection into your Elixir runtime from outside of the runtime itself. So if you want to get information of a PID, you need, as Ray explained, some facilities on the Elixir side that runs the bridge that given some piece of information, give me whatever I want to know about it. So I think you'll need, I don't know, a helper process running on the Elixir side that you can query for additional information that you cannot get from the data structure itself. So such as
I
PID
think like
sports and whatever.
the registry might already know some of this, but not all of it, right? It's the registry in Anoma/Noma is doing serving a specific purpose. So you probably need like it can probably be an instance of registry or something close to it.
By the
Oh
way,
yeah, I guess it depends what you want to know, but that's all I'm saying.
you see this, Christoph?
Yes.
I just called sys.getStatus from here. So I can do that from GT because I can run any function that Elixir can run.
Right, so you actually do
have
have the
everything.
primitives available. So yeah, you don't need a helper process then.
No, I have
Can you
literally
pass back a
everything.
PID?
Of course. Yeah, what do you
Well,
want? Like
then do
self
just
does return a PID. Look at
sys
this.
info for a PID, and then
Yeah.
you get all you want to know. So if you want to know if something's a gen server, you just
This
do
failed. I'll look at this. I think I accidentally didn't put enough parentheses or something. Is sys.info not a thing?
Yeah, I don't know.
Yeah, sys.info isn't a thing.
Is it inspector whatever?
Well, I can call inspect if you want. I can call I think it's ix.inspect. By the way, it actually highlights things. Okay, inspect self. No, do I not know how to spell inspect? Do I not know how to do ix.inspect? What is it?
Info is in the Elixir process module.
Thank you. It's info.
It's process.info.
Yes. Well, there's also this too, which returns a tuple. I also need to make a better printer because you can see that the tuples just return tuple rather than the actual useful thing. But yeah, see, you can see here that the data type is PID. It's alive, it's a name, links, it's a message queue length, description, and process node knows about this. I do process.info too. But you can see I need to improve my printers. Yes. I mean, look at this.
Yeah, and so these things can be useful members of the PID class.
Yes. Yes. But notice that every time I
there's
look through
like
this,
some of them are just like the some of them should be their own classes as well, right? Like the macro environment should probably be a class.
yes, it should be. I agree. There's a lot of work to be done. By the way, you know what's interesting? You can see that this thing is lazy because if I expand something like here, notice that as soon as I expand that, you get a bunch of messages here. That's because I don't actually grab this data until I go inside. And now it spams me. It's actually lazy. So, yeah.
But really, what should be a class is process dictionary.
Is it not? Is a process dictionary not a class? Okay. Does anyone have any other questions? Wow, that's
The
Mhm.
the object hierarchy, or like the the Mondrian view that you showed. Could you bring that
Yeah.
up for a second?
The Elixir or GT side.
GT side, like the
Sure.
the
This thing
that
here.
one. Yes,
Yep.
this.
Yeah.
Could you? I know you already went over a little bit of this, but if you could just like stay on this page and go over like what the core components are.
Sure. Let me move back some things because I moved something before because I was like, I don't want to look at it anymore. Okay.
I think it's
Cool.
a good place to end off to just go over that.
Yeah. So you have the serializer here. This has a few objects, like we see, like you have the beam proxy object, which is just the proxy object in which things inherit from, like list, PID object, stuff like that. So these are just the proxy objects that we noted. So besides those, we have the serializer. So the serializer doesn't do much. In this case, it's literally just copied. That's why there's no code here. You have also in the serialization the views here. So you have like the editor view here. So it's just some ways of doing some things. Let's look at something more like here's the list one. Apparently you can grab some data from it and create the list. And so, if you wanted to make your own Mondrian views, you can. You can make your own Mondrian graph if you really wanted from the view system. So that's what these are. And these inherit from GT view declaration, which has a few methods that you can see here. Next, we have the Leoparder page. The Leoparder page is how it actually gets stored and gets saved to disk. So there's the Elixir snippet. There's some application strategy on how the application works, like if it's running and whatnot, and like just how things get displayed. You have the snippet element itself. Just has like a couple methods displaying how it works. This entire Leoparder thing uses model view controller. I'm not an expert on this. I think internally Christoph knows the most about it. I've read up a bit about it. I'm not the greatest, but it's a model view controller. So that's what all these classes are. Then you have stuff on the execution side. So for execution, you have the ability to send links to your thing. So if you can see here, this thing's what set up the eval.notify. And you have the ability to just send the command strings themselves. So really, all I really had to define was set notify to instruction to basically parse Elixir. Okay, see ya, Michael. You have to parse Elixir here. Then you have the coder. And the coder is just the thing that lets you press play or whatever. I think this is like this gets added to the Leoparder snippet too, I believe. I'm not an expert in this. I want to add Elixir code to the actual coder itself, so maybe it's not hard. I think maybe you can even do it actually, yeah. Eventually, you could be able to program Elixir functions like you implement GT functions. Like all of these can be done because Coder is an open tool. So you can do that through Coder at some point. You have the Faro broker that I wrote, which handles the encoding differences. And then you have the application, like the global application. There's only one bridge per GT instance currently. I'm sorry, I don't have it, so you can play with multiple versions of Elixir at the same time. I should have this. This would be a cool way to pass one Elixir version to another. And I'm sure probably Christoph would be interested in helping me on this at some point, because I think you find that neat. So that's what this is. Completion strategy, I made this and I did nothing, but if you want to implement completion, just implement GT Elixir completion. And if you implement this, you get auto completion. So you can fix it. You can fix not getting auto completion. Process, so you can spawn a process through the Beam platform. I basically do some stuff there. I also make sure that I set up the repository. So I use Git to basically get a repository for it. So I clone the entire repository if you're not running an external Elixir bridge. So I fetch some things. You may have issues with this where it may not fetch the bridge for some reason if your Git isn't set up properly. Last up, we have the visualization code that you're looking at right now, and that's that's this code right here, made by that Stephan fellow. And that's all the code. It's kind of complicated to get started with if you're talking about the GT side, but this view helps a lot. And if you're talking about the Elixir side, it's a lot of work, but it's not too bad if you know Elixir. I actually find it's quite reasonable, and the code is, I would say, decent on the Elixir side. What it takes to write a bridge is not that hard. It's just a lot of knowing plumbing. And that's everything. Okay.